In this lesson, I'm going to teach you how to do net ionic equations. All right, so what we do here is we're accounting for all of our electrolytes. Anything that's aqueous is going to break up in solutions, as we've learned already this week. And now we have to account for things that become ions and always stay ions, or things that are going to come back together to make compounds that are no longer soluble. In essence, what we're doing in this lesson is bringing home what we did over the summer when we learned about driving forces. So these driving forces are going to be things that come back together and no longer make ions. So let's learn by doing some examples. Let's take the first one here with potassium phosphate. So we get K3PO4 aqueous plus calcium nitrate aqueous, and this is going to be a double replacement reaction, so you just do your swap. KNO3 aqueous, and then we'll have calcium phosphate, Ca3PO4 which is a solid. That's a precipitate, so that's your driving force. Now we're going to go through and break up anything that's a strong electrolyte. That means aqueous salts. Everything that's aqueous is fully soluble. It's broken up. So we'll have here, I need to balance my equation first. So let's go back, and we need 2 phosphates. We need 3 calciums, and we'll need 6 KNO3s. Okay, now I'm ready. So I have a grand total here of 6 potassium ions. We're not going to worry about writing aqueous next to those. 2 phosphates. I'm going to have 3 calcium ions, and I'm going to have 6 nitrates, 6 potassiums, 6 nitrates over here, and then I'm not going to do anything to this calcium phosphate. It's a solid, it's not an electrolyte, or at least not a strong electrolyte, and we're just going to bring it down. Only breaking up aqueous stuff here that's a strong electrolyte. Now, everything here that is an ion as a reactant, if it's an ion as a product as well, it hasn't undergone any change. We're going to mark those out. We call those spectator ions, and we have a couple in this reaction. The potassium and the nitrate always stays in solution as ions. So that leaves us with a net ionic equation of 2 phosphates plus 3 calciums to form calcium phosphate, which is the precipitate. In essence, what we have as a net ionic equation is an expression that explains to us how we made the driving force. In example number 2, I've written the equation for you. Now let's go through and break up all the strong electrolytes, the aqueous. So we have barium plus 2, we have 2 chlorides, 2 sodium ions, a sulfate, and then as products I'll have 2 sodium ions plus 2 chloride ions, and barium sulfate's a precipitate, a solid, so we will not break it up. We're just going to keep it with us. Now let's check for spectators. On each side I see 2 sodiums, I see 2 chlorides, and nothing else. So my net ionic will be an expression that explains the formation of my driving force here, the precipitate. Now let's skip down to number 5 because I have something a little different to show you. This is sodium fluoride, aqueous, hydrochloric acid, which is a strong acid, and that's important to remember because strong acids are strong electrolytes. We'll make sodium chloride and hydrofluoric acid. Now you have to remember that hydrofluoric acid is not a strong acid. That's going to be very important, so follow along. We have sodium ion plus fluoride ion plus hydrogen ion plus chloride. Okay, we break apart both salt and strong acids. As a product, sodium is broken up, the chloride is broken up, but we will not break up hydrofluoric. It is a weak electrolyte. Okay, so weak electrolytes do not get broken up even though they are aqueous, only strong. Now as we mark out our spectators, we see that sodium is one, and so is chloride. So we're going to have fluoride plus hydrogen ion coming together to make our HF. And while you're thinking that may be really new, remember that this summer I had you guys list driving forces for reactions, and one of them was the formation of a molecular species, a weak molecular species. I was giving you a preview of what a weak electrolyte might look like. Okay, we're going to finish up this example with a single replacement reaction. Let's look at number 8 on the back. We have zinc, and we're going to add hydrobromic acid, which is a strong acid. Yes, it will be broken up. We'll make zinc bromide, and we'll make hydrogen gas. Okay, so there's a couple things I want to show you in this example. One is that this net ionic concept works for both single and double replacement reactions, and it also, we have a gas down there. All right, so zinc, that is not an ion, that is a solid metal, so we leave it. Let's go back to the original. I forgot to balance it again. Let's put a 2 there. So we'll have 2 H positive plus 2 Br negative. We're going to break apart our salt here. Zinc plus 2 plus 2 Br negative. And we're going to bring that gas down. We will not break up a gas. All right, we're still going to look for spectators. I only see one this time, and that's going to be my 2 Brs. So my overall reaction will be zinc, which is the solid, plus a couple of hydrogen ions. And then we will have zinc plus 2, which is aqueous. So it's not the same zinc. They didn't cancel out. One's an ion, one's an atom. And then we have the H2 gas. Okay? So remember, we're only breaking apart strong electrolyte, aqueous stuff. Bring solids, liquids, and gases on down. And we're showing the driving force in the reaction. Even in this single replacement reaction, the driving force here is actually electron transfers. So we're having, it's not shown, we'll do this later, but 2 electrons are being moved, and you can see it from there to there. Okay, it's actually losing 2 electrons. And we'll cover that later, but that's the idea behind net ionic reactions. The AP test says that anything that's a strong electrolyte, you have to break it up in your final answer. Net ionic equations, unless otherwise stated, are not optional. You have to report your answers in net ionic equation and cancel out those spectators. All right, finish the rest of these for practice, and I'll give you some additional practice to do on your own.